Okay, so in second part of the series of this video, let us discuss the sum to infinity. We know that s is equals to a 1 minus r power n divided by 1 minus r is the formula used for sum of geometric progression. Now we have a very interesting situation in geometric progression, and that is, let's say you are depositing 5 rupees somewhere and you intend to deposit in multiples of 2 next day, 10, 20, 40, 80, and you will never end depositing this amount. Well, obviously if you are depositing 5 rupees and you will deposit twice the time next day and twice the time the third day and continue so on, there can be no sum, and you will keep on depositing. Your deposits will keep on increasing and they will move to a huge amount. But if you keep on depositing, there will be a never ending sum. But yes, if you deposit, let's say 5 rupees today, and you deposit half amount the next day, which is 2.5, and half amount the next day, which is 2.5 into 0.5, which is 1.25, and half the amount the next day, which is 1.25 into 0.5, which is 0.625, and keep on continuing. There will be a day where you will be depositing something, obviously, but your sum will not increase. It will be a deposit of 0.000000001. So the geometric progression says that if you have any a, let's say 5, but if your r is less than 1, and you want to find sum to infinity. Sum to infinity means that if you don't have a limit, if you don't have n, if you are not depositing for, let's say, 4 days or 3 days or 2 days, because if you are depositing for 2 or 3 or 4 days, you can actually add all the values and calculate a sum for those number of days. But if you intend to keep on depositing forever, if you keep on depositing forever, you can actually know today how much can you deposit and how much can you have. And for that, it uses a formula which is s is equals to a 1 minus r. Now firstly, let us say that a man deposits 5 rupees on the first day and he intends to deposit in multiples of half the next day and keeps on depositing this amount forever. And the question asks how much will his deposit sum up at the end if he keeps on doing this practice. You will say it will end up to 5 divided by 1 minus 0.5 is equals to 5 divided by 0.5 and is equals to 5 divided by 0.5 or 10. Okay, if you keep depositing 5 rupees today, half of that the next day, half of that on the third day, half of that on the fourth day, and continue to deposit this amount, you will be able to deposit, or you will be able to accumulate only and only 10 rupees. So this is the formula for sum to infinity. Now let us discuss how it is actually derived. We know that when we had number of years, the formula we used was s is equals to a 1 minus r power n divided by 1 minus r. Can I write it like this? A divided by 1 minus r minus a r n divided by 1 minus r. Yes, I can. I broke this terms into 2, so I can mathematically do that. Now the condition for sum to infinity has one condition, which is r should be less than 1. If it is greater than 1, you will keep on having a good amount of sum. There will be no end point of sum. But if r is less than 1, only then you can calculate the sum to infinity. Now how can I calculate the sum to infinity over here? If r is less than 1 and let's say n is, let's say, 1000. By 1000 I mean that n becomes very large, very large. So r power n or 1 power 1000 will become 1. And if it becomes 1, r should be less than 1. So let us just change our example and take r as 0.5 for anything which is less than 1. Power 1000 will be equal to 0.5 power 1000, which is 0. R should be less than 1 and there should be no n. Why did I took n? Just to prove that if n is very large, it is infinite, r power n eventually becomes 0. And if r power n becomes 0, a divided by 1 minus r minus a, r power n becomes 0 when n is used, divided by 1 minus r. This will be a divided by 1 minus r minus 0. So that's why we use a sum to infinity, formula for sum to infinity, as a divided by 1 minus r minus 0, which is a divided by 1 minus r, which we did use over here. That's the end for AFC students. You can stop watching video over here. I will be deriving the dividend valuation model and let you know why to use the dividend valuation model the value of growth rate should be less than KE. Let me write the dividend valuation model's formula. P0 is equals to D0 multiplied by 1 plus G divided by KE minus G. So this is the formula which we need to derive now. The dividend valuation model says that the value or the market price of a share is the discounted value of all its future dividend values. Let's say we have year 0, year 1, year 2, year 3 and so on. So the market price is calculated over here, and as per dividend valuation, it is the discounted dividends of all the years of D1, D2, D3 and so on. If we discount all these dividends, we will come up to the market price of the share. That's it. Okay, let's say that the growth rate is G, the cost of equity is KE, and today's dividend is D0. Therefore the year 1 dividend will be today's dividend multiplied by 1 plus G, and to calculate its present value I should divide it by 1 plus KE. Year 2's dividend will be D0 1 plus G power 2 divided by 1 plus KE power 2. Year 3's dividend will be D0 1 plus G power 3 divided by 1 plus KE power 3, and it will keep on moving on like this. And if I discount all these values, including anything over here, I will get the value of the dividend. If I discount all dividends, I will get the value of the share or the price of the share. So understand what are the relationship between the powers of both of these. This is 1, this is 1, this is 2, this is 2, this is 3 and this is 3. I will continue the derivation in the next part of this video, since the length of the video has exceeded a good amount, and so it is difficult to upload the videos. Thank you. Do watch the next part.